Hi guys, let's do same tree. So we're given the roots of two binary trees, P and Q, and they want us to write a function to check if they're the same or not. And they tell us that two binary trees are considered the same if they're structurally identical and the nodes have the same value. So we're given an example where we have these two trees and we output true because as we can see, these are the same tree. In example 2, we output false because these are different trees. And in example 3, we output false because these are two different trees. So basically, we're going to want to do a DFS on each of these two trees at the same time and compare node by node as we visit each node. So if we start from the root at 1 for each one, and then we go down to the deepest path, we'll be at this node with a value of 2 at each one, and then we'll compare these, and these values are the same. So far so good, and then we'll check this node's left and right, and they're both null, so there's nothing to explore there. So we'll go back up to the 1. We'll compare the 1 to the 1, and these have the same values. So then we'll go down the right path to the 3, and we'll check the 3 with this 3, and they're the same. So everything's the same, because if we check the left and right path from here, there's nothing there, it's just null. So this one is true. And then for example 2, we'll go down the deepest path to the left, which is 2 in this tree. We'll go down to the left in this one, which is null, and these do not have the same values, so we'll return false. In example 3, we'll do the same thing. So we'll go down the deepest path to this 2 and this 1. We'll compare their values, and they're not the same, so we can just return false. So we need to consider our base case. So for our base case, if both of, like in the simplest form, if both trees are empty, so both of these nodes will be null, then we can return true because they'll be the same, because they'll both be an empty tree. So if P is null and Q is null, we'll return true. And then, so if only one of them is empty and the other one is not, then they're not the same. So we can also do a case for that. So then we can say if P is null or Q is null, then return false. And we can say or because here we already checked and. So if we say or here, that means only one of them can be, but not the other one. Because normally it's like one of them or both of them, but we already checked both of them here, so it's not including that. Okay, and then from here, we want to check if, so like if we think of the next most simple possible case, then we would have each tree would just be one singular node. And so we would want to check if these nodes' values are the same. So if they're not the same, then we'll return false. So if p.val is not equal to q.val, then we'll return false. Okay, and then from here, then the only possibility, because these are already like our most simplest cases, so then there must be more tree, right? So like for in example 2, at the very bare minimum, if we've already done these 3 cases, so we will, like if we're at node 1 here, we're going to want to check that all of the nodes on the left subtree are the same and all of the nodes in the right subtree are the same. So we'll just return this, and we'll call this same method again for the left nodes and the right nodes. And that should be it. Okay, and then our time complexity is O of n, where n is the number of nodes per tree. Technically, we could say the number of nodes in the tree that has more nodes. I don't know if in these examples they all have the same number of nodes, but I suppose you could have a case where, like, I don't know, one tree only has like 2 nodes and the other one has 10 or something. But that is because, so this is because we're visiting every single node in each tree once. And even though there's 2 trees, like, so it's technically 2 of n, we'll just simplify it down to O of n. And then space complexity is going to be O of n as well, because we need to add all of the nodes that we're visiting onto the call stack. So that's it for this problem. Thank you guys for watching. Bye.